Hey guys, how's everything going? This is Json. I hope you're still interested in React Server components because it's still one of the hottest topics on the internet. In one of my previous videos, I've shared with you how I created something similar to React Server components by looking at its demo, and I think it's pretty interesting to move how we manage to move the dependencies from client to the server and achieve possibly some performance gains. At the end of the episode, I've shared my plan was to first try by ourselves and then compare with the actual implementation. And here we are. I've read the internal source code about React Server components, and this is the video about me explaining it. It's quite long. So if you prefer text, please go to json.dev, and there's an episode say how do React Server components work internally. It's part of the React source code walkthrough. I'd like to point out that still the React Server component is still under development, and it might change anytime in the future. But I think the idea, the direction is still the same. It will be the same. So yeah, let's first start with a recap on my previous episode. My approach was when we build the components on the server, we would try to differentiate if the component is client component or server component by looking at the use client, use server directive, and this is just a simple implementation by using a like component map, which obviously is not the actual implementation, but you get the idea. And then when the React tree is rendered on server, we will recursively render all the elements for server components. We will replace it with a component that force suspending. So by force suspending, I will just throw a dummy promise. And then for client components, we just replace with some built-in client component. I give it the name of lazy container, and which is built in on the client. So they will get the component name and try to fetch the source code, JavaScript code on the fly. So yeah, and when we recursively render the React tree, each time we see some async components, we will create a different chunk and send it to the client by streaming. And to differentiate each chunk, we give it an ID, alt incrementing ID, and on the client we will get each chunk, and then we just used a state, use the state hook, and each time we would merge the chunks to the base chunk. So it's quite simple. Yeah, this is on client, blah blah blah. We force suspending for the you can see like it's a placeholder for the sub component, and it doesn't matter because once it's fulfilled with the real JSON data, the component will be gone. So this is our guess. Let's see how it actually works. So this is the actual RSC demo. So this is the render React tree from the server. We get the manifest, we got the module map, and then here we render to pipeable stream. This is similar to what we were doing, right? Render to stream and pipe. This is the add element React app, and yeah, this simple. And then we pipe to response. This is actually similar to what we did. Recall. Let's see, what did what. Yeah, we just render server component to stream, and the response. First one is the JSON, the second one is response, but we render it here. We call the component already. This is the first try. Yeah. Oh, this is the last episode. Sorry. So this is a bit different, but I think that generally it's similar. Cool. And on client, it's a bit more complex. So for RSC, it requires us to basically do the fetching on the router level. So here we use the location for key, and for each location we will get the response from over the network. You can see here we render React, and this is the location, and all the I think there will be some parameters encoded here, Anyway, so each time when the location changes, it will try to fetch the actual page, the rendered React tree from the API, and then set it with hold it with a state in order to avoid the unnecessary suspense. We'll use the start transition. If you're not familiar with transition, actually I have an episode on how we here transition. Yeah, transition works. I haven't done an episode for it yet. Oh, already. This is old debugging one. Okay, cool. Yeah, and then we just render it with use. So in this demo, we have 3 problems to investigate. The first one, render to pipeable stream. How does it work? And the second one is create from fetch. How you handle the stream data, and the third one is use. How you render the data with this use. Cool. The first one, render to pipeable stream. This is the source code. We focus on 3. I think this 3 locations. First one is we'll create a request, and there is a field called model, and this is start work. Actually, just start the work per name. It just kicks off the whole process, and then pipe. Obviously, it just sends down something through the stream. The request is the object to hold all necessary info. We have this thing called context in our demo. Do we have the context here? Yeah, we add the context in episode 6. It holds something. What is it? Yeah, ID, which is the chunks incremented ID, and the tasks. It's to handle like pending tasks, something. Yeah. So this request actually plays the submitter role. You can see that next chunk ID is actually increment ID we were using. Cool. The pending chunks is like our tasks. This is okay. This is a counter to check if everything is done. And this one is a bit different. Is that it holds the completed chunks before it sends down. That's because while in our implementation, we just flushed it every time a chunk is done, but here it won't send it down unless the pipe function is called, right? So it needs to store the status. So you can see that the request, per its name, it's like a request to render a React tree, but obviously we have multiple steps on it. Like first we render the root level, and then layer by layer we render deeper, and for each chunk it has the status of it's being rendered or it's done, and also the ID. If you want render a new chunk, we need to get ID stuff. So this all is for makes up this request, and this request is working like the request in HTTP server, right? In Express, I think if you know about middleware. Every middleware just to process the request and add new data to the request so that each the latter middlewares can handle the request. Cool. This is a request, and oh yeah, this is the to JSON is per its name. It's like a serialized function so that the data rendered data could be transferred over the network. But it's quite complex. We'll cover this soon. Okay, so this is a request, and start work actually kicks off the rendering. Here's the perform work. For perform work, you can see that here it says for each task we will retry the task. Forget about the name; it's a bad name here. It basically means that run the task. So this is also it's synchronous. You can see that this is not async. So we retry run the task, all the tasks, and then flush the completed chunks. Cool. So this is basically how what performance work does. And for pipe, pipe is the pipe here. Pipe. Where's the pipe? Yeah, here pipe. You can see that pipes to the response. Okay, pipe here. In the pipe, blah blah blah. You can see that there is a destination right. This is. I had a demo about the stream, so it's pretty similar. Yeah, you only need to remember this. Cool. So we have the concept of request and the task actually means one chunk. For create task, where we are, we have the create task somewhere. Create task. Oh no, no. There is. Actually, it's in a we first create request. There is a create task here. So create task. We have the model, which is a React tree, and then you can see here for each request, for when we create a task, we get the next chunk ID from the request, and then we auto increment it and get the ID and create a task and to return the task. So yeah, this is the create task because for each create for create request, this will be the only one created request for each API call, and then we will create a root task, and yeah, and we will start working on the root task. Retry task, which is basically, I said, it's run task. It's a huge try catch block, and it will render the model React tree for if only it will process it if the root is some React element type. Basically means it's not intrinsic HTML, which is pretty obvious because if it is the root level is intrinsic HTML, we don't need to do anything, right? Intrinsic HTML, which we can already serialize it. All we want to handle here is to handle those server renderable component. So here it is. This is for check React element. Oh yeah, sorry. This doesn't check the function. Function here is attempt result element. Yeah. So here is that for we need to notice that this only calls for once attempt result element, and this one is some performance tuning we can ignore for now. Yeah. So after we render it, attempt resolve it. It should be ready. It is actually not ready, but it's ready for this root level. And then we will put the process chunk into the complete one, and this will be later be flushed. Yeah. Remember, there's a try catch here. So if we have some error, obviously, if it is a promise is thrown, it means that we need to suspend, right? If we render on client, here you can see that if a promise is thrown, it suspends. We check if it is thenable by the then property, and then it will do what? It will actually rerun the task. So the task is the pin, and then it will pin again. Yeah, this means that it will just retry the task, and flush complete task is not here. It's outside of the retry task. Yeah, pin task is actually perform work at the request. No worries. As I said, attempt resolved element. Why it's attempt? Because it might be intrinsic HTML. So it's we just try. It doesn't necessarily mean we need to resolve them. It's only renders it processes once. It doesn't. There's no recursion inside. You can see. So this is the function attempt resolve elements. Let's see. It's quite big. Let's see what they are. So here it's check if it is client component, and it return this array notation. As we have covered it before, this actually on the client side is an object notation. So this one is type, I think. No, symbol for, right? Element type something. Anyway, and key props. But there are quite a lot repeated. If we put it in an object notation, there will be quite a lot of repeated keyword stuff, right? So this is actually a improvement so that the serialized data could be more compact. It's not that important. Cool. So here, type if it is function, if the client function, as we said, if this client function, it will be loaded on the client. So there's nothing to do more on the server. So we just, okay, so it say, okay, this is what we want, and it's rendered. Now we are ready to serialize it. Serialization is after this. Cool. And this one, so yeah, this is server component. We run it, and then if it returns, say, promise, if it is already fulfilled, then we just return the value. So it's quite good. We didn't do this in our previous our own implementation. If not, it means that as we said, as what we did is that we place a hole there which forces suspending. Here it's create a lazy wrapper, a bit similar, and then this will be ready for serialization. So let's see what's inside of a crazy lazy wrapper. The wakeable is the promise. Obviously, the enable should be throw, I think, and so we can schedule a new task, right? So yeah, here. So this is the lazy wrapper. We would use a lazy type. So this is a bit different in our implementation as well. We didn't use the lazy. Okay, it's not. Yeah, this one is take full advantage of the built-in types. Cool. For a lazy type, there's a payload, and then there's init. Init will be used when we read the enable, and if said it is not ready, then it will be throw. What does this mean? That if we take a look at the branch for the React lazy type, you can see that it will call the init. So if it is not ready, and the init is called, the promise actually will be throw. So this actually it will go to the catch branch. Where are we? Here. You can see that here. This is the catch branch. It will go here, and the task will be retried. Awesome. Yeah. So and for client component, yeah, as we said, it's already ready for serialization, and intrinsic it's already okay for serialization. For like simple, yeah, for React fragment type, we just use the children. It doesn't need to be. There's nothing need to be done for this one. Otherwise, yeah, we can start serialization. Process model chunk, I think where it is here. Here. So for the roots, we process it for one layer, and then we will process the model chunk. Obviously, the server components or client components deep in the tree is not done in one call of a temp resolve element, right? So, it actually lies in the process model chunk. Let's see what's in the process model chunk. Process model chunk. Yeah, here. Process model chunk, it will call the to.json, as we mentioned before. To.json works as a replacer, as a JSON stringify. This is a demo for what is a replacer is. So this is the origin, the target object. This is a replacer. It means that replacer could replace the data for specific key. Like say, okay, if the k is A, we will return B and 4. If it is B, we return C and 5. And we return, if otherwise, we just return the original value. So after this, you can see what we get is A, B, C. This is interesting because the one thing we need to learn to remember is that the data returned for the replacer will be processed as well during the process. So we return B and 4 here. So B and 4 will be processed again, and you can see that B applies for this if branch, and then it will return C. So this means that we could update the object on the while we are serializing it. So it's perfectly match our needs here for the server side React tree rendering. So for the process model chunk, it is done as that. So it will use this resolve model to JSON as a replacer. Resolve model JSON will works as the replacer. Let's see what's inside of it. So it says if the value is element type, we use this one. For our implementation, we use the full string, but actually in a React tree, this will occur so many times. So they choose the small, shortest form with a dollar sign, which is pretty clever, I think. Okay, for server components, again, we met this. This is the server components deep inside the tree rather than the root one. So basically, I think we're doing the same here. You can see that for here, we will try to absorb it, which is the same function we've talked. And for React lazy type, it will call init again. So if it is not ready, it will throw the promise. This is interesting is that keep in mind that, as I said, the data will be modified, could be modified on the fly when we are serializing it. So if a server components is like this one, it's a server components. For the first time we see it, we will change it to the attempt resolve elements will return a lazy wrapper, right? Which is React lazy type, and then actually this process, the serialization, will work again on the React lazy type. Now it throws. So and interesting is that we will keep all the data, so it will not render from root again. It only renders the subtree here. Cool. And for React lazy type, this time if it throws again because it's not ready, it will do something similar to what we saw before for the retry task. But there's a thing, it does not retry the task, but it will create a new task here. Create a new task and schedule it. Cool, and serialize by lazy ID. And serialized ID is well, just use the $sign plus L means lazy, and the ID. Yeah, it's different from what we see in a retry. Cool. So this means that for a server component, will transfer it will change the lazy type, and if it is not ready, this will be sent over the network, and a different task will be scheduled with the SID, and it will be sent over the stream in a different chunk for the subtree. Null is just to use null because null is serializable, and client components, it basically just yeah, it's nothing. It's still using the lazy ID, but it will create a different module chunk. This one checks because if a client component is used multiple times on the tree, we doesn't want to lazy preload it for multiple times. So this is a check for duplication, and also a component, a client component might be used as a property, props, not as an element. So it checks for the position here. If the keys, if it's the second element in the array, it means that it is used as element. We need to render it. But if it is a props, it doesn't necessarily mean we're using it right away, right? It will be could be used in some in certain condition. So we don't render it now. Cool. And yeah, I think for the client component, it's similar to what we did lazy container. It's not that complex here. Yeah, and so yeah, and for this is a bit complex because as we see that it gets the module information from the here, from the module map. We didn't do this actually. We're just using a name, a rule. Yeah, it's I think it's basically the same. Just to remember that this needs help. The help from the builder bundler is requested to emit the import chunk, which is the module chunk. You get the data from there. Yeah, cool. And for then a promise, it's also serialized the lazy chunk with the ID. This could be some like promise. They're not from the client component. They're not from the server component like async module. It's just a purely like you're fetching some data, which is a promise, and used as a, if it is used as a props, we need to serialize it. Cool. It's basically the same. And yeah, basically same as the lazy chunk. And for primitive values, they are serializable, so they're just using it. And symbols, I think, yeah, symbols just okay, similar to client component, built-in symbols generate import chunks. This is cool because yeah, not every component needs to be are used on the client, right? And I think it is it's like we only load it when it's used. It's pretty cool. Cool. So after this, you will. I have this question. Maybe you're asking as well. Is like while we're handling promise in two locations, as we see that attempt resolve element is used in retry task and resolve model to JSON as well. And there are two error handlers in retry task and resolve model to JSON. The difference is that in retry task, it will not schedule a new task, but it will retry the task from the root. And for resolve model to JSON, it will schedule a new task. And it will be a new chunk with a different ID. So why is this? Is that actually we didn't do this in our implementation, but I think this means that for the root level, for the root chunk, it will always be ID 0 because we started with 0. So if suspense happened in the root level, it will retry the task still with the ID 0. It doesn't schedule 1, right? So the ID 0, it will always be meaningful. I think that's the goal for the different handling here. Another question is how to tell if component is client or server component. This is interesting, is that for server, it's actually just check the on the server, it will take advantage of the some hidden API from Node.js. It's called module compile. Let's see a simple demo. So on Node.js, we know that we do things as required, right? So like say for a module A, we export the an object with the value 3 on the property A. So we import here, we require the module and we log A. Let's see what it is. You can see that it's different. It's not A3, but it's B4. That's because of require actually is the require is I think it's a method on the module of module. This module has this compile method which we can override. Like say, okay, we override this compile with say, okay, the export of this module is before, so we override the behavior of require. And in the React code, it does the same. So you can see that it overrides the require and check if the content has this use client or use server directive, and then it will set up the some extra property on the exports. So we could then later check if a component is server or client by compare the tag, which is quite hacky or clever. But anyway. And flush completed task just to stream down the chunks. This is nothing special. Just remember that there are different chunks. This is import chunks for the module. This one is completed JSON chunks. It's just React tree chunks. The most, so for the tree, subtree stuff. And this is error chunk. We won't cover for now. So yeah, this is basically how the render of server-side component, the server rendering React tree on server works. Let's take a look at some of the real stream data to understand it better. So here we have a model of HTML, and then this is for HTML. We have this div, including two text. Two text is just the intrinsic HTML as well. So this tree, there's no async components, no client components. It's just a pure HTML. So when we render this, it will be synchronous, obviously, and then we see this. This is the row transferred over the network. So there's will be only one chunk, which is ID 0. In here, we get the HTML, which is this one. And then this is the first element here. You can see that it's element and this div, and this props. No, there's no props and children, blah, blah, blah. So yeah, it's basically the HTML stuff, all rendered. And also, there's a part is that you can see that this one is gone, right? We don't need this, so this is a good part from our server is that we will skip the unnecessary layer. Cool. And if you have a single server component, this one text, delay text will throw a promise it's async, and in the text it's just the children. Cool. And we have this model with a name. You can see now it is that we have this root content here, and then because this is async, it will be as we said, it will be wrapped as a lazy wrapper, and so this lazy and one, and later when it's resolved, it will be streamed down with the new chunk will be streamed down, which is this one. ID is one, obviously, and the content is JSON, and this one is the whole here connects to this chunk. If you have nested server components, it will be the same, like because this is async, so it's a whole. So waiting for the chunk, and this chunk when it's rendered, its children is another async component, so it will be a placeholder for another chunk too, and in the end, this chunk is generated is JSON. So this is the 3 rows over the string. For suspense, it's quite simple. As we said, it generates another import chunk. So this one is import chunk, and this is the root contents. This one is it's not lazy anymore. Here, yeah, and we have a lazy chunk here, which is the name, JSON. Client component. So this is a client component, and you can see it's a slightly different. Again, it's lazy chunk. It's same as server component, but there's an I here, means that this is a module chunk. It's for client components. You can see there's a name and async, ID, blah blah blah. So this one will be handled differently. It will possibly start the preload. Cool. Yeah, this is all some basic examples about the stream data. So the last part is how we render this data on the client, right? So here is the response something. It will, what is it? It will create a flight response, and to understand this part, we need to we'll try to figure out the 3 questions: what is flight response, and how this start reading from stream works, and what does get root do, right? Okay, for flight response, it's quite big, but generally we need to remember that it's just this data structure that holds chunks. As we said, there are different chunks, right? Chunk 1, chunk 2, which identified by ID. So this is like a data holder to hold the different chunks, and it has this property. It has this what is? Oh no, it is this create from JSON callback. Where is that used? Options. Where is this one is used? From JSON. Oh, okay. So it has a from JSON. Has a from JSON. Oh yeah, here. So this is create response. This is the base. So this response obviously holds the chunks, and also it has a from JSON, which is a way that it's basically a function that tells you how to generate these chunks on receiving the data. Cool. So create from JSON callbacks is it returns a function. Returns here. Yeah, it returns a function, and this will be used as reviver. We see that when we are serializing it, we need a JSON we need a replacer to replace the serializable data. But while we are receiving the data, we need to reviver to revive the origin data, right? So here for React element type, we'll transform it into a $, but now we need to switch it back. Cool. For example, if a lazy load, we would create a lazy chunk wrapper chunk. Yeah, so far. There's quite a lot of different identifier here. I'll skip them for now. Let's just look at some basic ones. So here is the element type, and this one without the L is the chunk ID, like the import chunk. We just use it like get chunk. Obviously, because for the response we can just get the chunks by ID, and then yeah, cool. And the other one is S. You provide symbols. Cool. So this one This S means symbol, so it will be replaced with symbol 4. Yeah, because this is the function. Cool. L is revived as React Lazy type. This is how the React Lazy works. Cool. Yeah, create a lazy chunk wrapper. This is the lazy type. And then Rechunk. Yeah. So Rechunk, you can see here, it says if it is pending, what do? It will throw it. Cool. So this is how suspense works on the client side. Obviously, we did this the same for the server, but in the server, we will schedule tasks to re-render something. On the client, if we throw a promise, as we mentioned before, it will create suspension, and the React runtime will try to re-render the whole React tree when the promise is resolved. So cool, right? And for when we render it, when we receive the data, this is a typical code for the body reader. I think quite some time ago I actually did. Oh yeah, this is the same as we did in the body get reader. This is a typical way of read the data. It was check if the down flag will be provided by the API. So if down, we don't do anything. If not, we keep waiting, keep reading the data. And when we get the data, we would process it. And so process is merely just decode because it's binary. We will decode it into text and append into a row. Here, if it is, as I said, if it is marked as I, we would resolve the module. And otherwise, we just resolve the model. It's a module chunk and it's a model chunk. So for model, we would resolve model chunk. This is try to resolve a promise from outside. Oh, there's a typo here. Cool. Chunk, I think we haven't mentioned chunk somewhere, right? So where is it? Oh, here. Chunk is here. Anyway, just here, remember, chunk is a promise. And it is a resolve module. Resolve module, you see that we will preload the module and use the promise. And then, yeah, use it, chain the promise for preloading. Resolve module chunk, and there's nothing special here. There's one thing about chunks here. Okay, it's getting the root. Cool. So in get root, we will get the first chunk ID. This is how you can see that the 0 is hard coded here. This answers question why why I thought that it is important to make 0 with the first chunk meaningful. And in get chunk, you can see if the chunk is not there, it will create a pending chunk. This is super important because the pending chunk is actually a promise. It's create a promise there, and it will expose the resolver. And here, it will expose the resolve to the world outside, so that when we get the data from the server, we could call the resolver and to resolve this promise. Yeah, you can see that it's pushed the resolve into the value. And for resolve model, we would resolve model chunk. Resolve model chunk, we will get the resolver from, and then you can see here, yeah, we will call the resolver. So yeah, so basically means that if you're rendering a lazy chunk, it will return through this promise. This promise will be resolved when data comes in. So yeah, it's pretty cool. The last part is use. The use is quite, I think, straightforward. We'll skip the details, but remember, it's again, if it is not ready, it will just throw. Cool. I think I've talked too much, but let's use this. Okay, wait a minute. So I can. This screen recording is not taking the full screen. Sorry, but I think yeah, it will render. Okay, so let's review our learnings today. This is server, this is over network, and this is client. So for server, we want to server render a React tree, not server-side rendering, render the root. And as we said, when we create a request, we have a root task, which labeled as 0. And so what will happen? React will try to render it, and so this is synchronous, and until we get the client, get the async component. For the client, we'll emit obviously the import chunk. It's synchronous, and for async, it's the server component. We would schedule a new task, right? So it's not 1, it's ID 2 or 3, and yeah, it's done. So for the 0, we stop here because it's done. This second task and third task will have their own life cycle. So it's done. So it's done. We mark it as different color. Now we will stream the rows. The first row obviously is a skeleton, like the initial React tree. We have the reference to the module and the second chunk and third chunk. And it will be, this is the network, the stream rows, and the client, when we receive it, we will create chunks from it, right? 0 obviously has the structure, so we have the data. And for 1, it's module chunk, so we start preloading. And for 2, 3, it's lazy chunk. We'll create a pending chunk, right? We will wait for the data to come in. So this kind of like works a placeholder. For all these 3, if they're used right now, they will throw. I promise. It will suspend, basically. So when we create the React Fiber tree, 0 you start with div, so with div, and then you will go 3 lazy, and all of them are marked rest because they're throws. And later, the 2, this one, this async components renders, it resolves, and it have the p tag, and inside of it is another server async component, so it schedule new task 4. But 2 is ready now, so it is ready for it to flush. So we get 2, and it has a reference to the 4th chunk, and when we get to 2, right, it is done. And then because it's fulfilled, but it has the reference to 4, so we create a placeholder for chunk 4. For 2 is ready, the render will continue re-render, right, as the promise. When it's resolved, we will start re-rendering, and now lazy got P, and it got lazy again because this one is the async component. So suppose like the preloading is down here, it will React will render again. So the client component here will render on the client. So it might render button, but on the client side, on the server side, it doesn't know because it stopped here. So this only renders on client side, and later the 4th, even though the task 3 is scheduled first, the order is not guaranteed. So maybe task number 4 will resolve earlier. It renders a span, and yeah, we will send a row through the network, and the chunk 4 is resolved, and the lazy here will be updated. Lazy span. In the end, the task number 3 finishes, and it renders a B tag, and it will be sent over the network. Client side will resolve the chunk number 3, switching from pending to resolved, and then this lazy will be updated. It's not updated from this component actually. It will be updated from the root. This relates to how React re-renders. Please, I think I've covered it for quite a lot of times. You can check on my blog, json.dev. Cool. And finally, render speed. So this is the general picture of how React server component works. It's actually not that complex. Let's go back to our blog. So comparing to our naive implementation, I think the actual implementation from React team is much better because we have enough things that undone in our implementation. We didn't maintain the correct semantics of re-render. This is the biggest caveat in our implementation, is that we use a state hook to try to merge. Like we get the data and then we try to merge the tree holding in the state, which is not good because if you check our post about how suspense works, the suspense re-render is actually happening on the low priority. So for this re-render on receiving the chunks, we're not holding the correct semantics. And also for the client component, we didn't do preloading, and also we revived the symbol at element level. Yeah, and we don't have the cache for chunks, and the merging is not performant. For the server, we didn't tell the difference from the root level rendering and the subtree rendering, which means we didn't enforce the integer chunk to be meaningful. And our approach is recursion. It could run to max call stat error if the tree is super deep, and because the React team asks you using the JSON string file, the native native method, it has this internal implementation which prevents the max call stack limitation happening. And also we didn't handle the manual throw promises, blah blah blah. So yeah, but anyway, I think we're on the sort of similar direction, and I think I get it right on the general approach, though without too much detail. So out of 10, I will give myself a number of 3. How do you think? Yeah, maybe you can find a better way to implement the React server component. Looking forward to your sharing, and hope this video helps. See you next time. Bye.